Greetings and welcome to the introduction to astronomy. In this week's Astronomy of Other Cultures, we are going to continue talking about Muslim astronomy and specifically look at the work of Thabit ibn Qurra and his contributions to astronomy and mathematics. So what do we know about him? Well, we know that he lived from around 826 to 901 and did work in Baghdad on astronomy and mathematics. Now he did a couple of different things, including translating works, which was a common thing at the time, was translating works from other cultures. So those of the Greeks, those of from India and other regions that were then translated and used by other astronomers. He also wrote original works as well. So we're developing again some more original work here by the science in the Muslim world. Some of the things that he did in astronomy, including measuring the length of the year and measuring it to an accuracy of seconds. So very precise measurement of how long the year is. Now the year is not necessarily a simple thing to measure. The year is how long it takes Earth to go around the sun once. But how do you tell when the Earth is exactly back into the same position? So it takes very careful measurements of the stars and observations over long periods of time to get this. He also studied motions of the sun and the moon. Now, one of the things we're beginning to see is the rejection of some of the things that Aristotle had taught us. Aristotle gave us a lot of different ideas as to how things might work. And it rejected Aristotle's idea that there was a natural place for each of the four elements. So that determined positioning as to where things would be. The Earth would sink down because it had a natural position to be lower than things like water or air or fire, and fire rose up highest in the sky. So that everything had a natural position and order to it. And that was why things would fall to a specific place. So this is his rejection of that idea that everything has a natural place. And we're going to see over the coming centuries that this will eventually lead to Isaac Newton and our understanding of gravity as to why things fall rather than things moving to their natural place. He also worked to reform the Ptolemaic system. Ptolemy gave us this system in the Almagest, a geocentric system that was used to explain positioning of the planets. Now it worked well, but not perfectly. There were issues with it. And as observations got better and better, modifications had to be made to explain the observations that we could see. Now that's the way any model works in science, is that you make your model and you use it to make predictions. And then as predictions are made, you can then refine your model. So here we're continuing on the refinement of that. And it won't be for another hundreds of years before we get to the point where the errors finally become too much that we have to throw out the Ptolemaic system altogether. Now in mathematics, he looked at the Pythagorean theorem and generalized that. So while it was known for a long time, a more generalized version of it. And he actually developed some of the very early concepts in integral calculus. So one part of calculus that would be used and eventually fully developed in the 1600s and used for various problems, including by Isaac Newton in terms of solving some of the problems of gravity. But the beginnings of calculus do go back here hundreds of years before Isaac Newton. So let's go ahead and finish up with our summary. And what we've looked at this time is the astronomer Thabit ibn Qurra, who lived from about 826 to 901. It was known for rejecting ideas of Aristotle, especially in terms of where elements naturally fall, and did work on reforming Ptolemy's geocentric system for the universe. He also did work on mathematics, including the Pythagorean theorem and calculus. So that concludes this discussion on Thabit ibn Qurra and his work. We'll be back again next week for and not to talk about another astronomer of the Muslim world. So until then, have a great day, everyone, and I will see you in class.